closely related to what we did yesterday. Yesterday we looked at congruent triangles. We found that congruent meant that it was the same shape and the same size. Today we're dealing with something similar. Similar triangles mean that they're the same shape, but they're different sizes. But we're going to be using a lot of the same congruency in order to make correlations. But the idea is that because they're similar, we can use proportions to find missing links. We'll start off with a basic example just like we did yesterday. We'll do a triangle, maybe 3 by 4. We'll make another triangle. It doesn't have to be exactly the same size as mine. And we'll label that A, B, C, and D, E, F. So what I'll do is I'll mark the corresponding corners, or the corresponding angles. Something interesting about triangles, what is the number of degrees inside the triangle? Natalia? Does it matter what size the triangle is? No. So one thing that's really interesting is that in similar triangles, whatever that measure is, like pretend that that's 45 degrees, maybe 50 degrees, actually looks closer to 40, that angle right there will be the same angle measure as that one right there. That's 90 degrees, that's 90 degrees. The size of the triangle does not affect the angles inside the triangle. It does, however, affect the lengths of the sides. So if I told you that that had a side length of 5 feet, 5 yards, 5 inches, 5 centimeters, and the bottom was 7, and the height of this one was 10, and the bottom we don't know, what would the length of that line right there be in our larger triangle? Michael. And how did you get that?
You took 5 and multiplied by 3 to get the height, so you take 7 and multiply by 3.
All right, so the strategy that you said was you multiplied by 2. You did 5 times 2, it gave you 10, so you did 7 times 2 to get 14. What's another strategy that you could use to get that answer? Anybody use a different strategy? This is really closely related to something that we've done before. Lena? So you did repeat addition. You just did 5 plus 5 to get that, and then did the same to get that. Any other strategies? When might this one not work really well? 5 to 10, and then 7 to 14. Haley?
When the triangles are they're exactly half.
Mm-hmm.
They're not exactly half. Then
Yeah, that's a really good point. We're dealing with super friendly numbers. We're going from 5 to 10. Most people can see that really easily, that that is twice as big as that, so that's going to be twice as big as that. What if I'm dealing with fractions or decimals? Do you think this strategy might be more difficult? Absolutely. Absolutely more difficult. So a strategy that we're going to use is the same one that we use for shadows. This is a man's height, that's his shadow. This is the pole's height, that's the shadow. So what we're going to do is we're going to create proportions. Our small triangle is 5 over 7. That number right there is our vertical height. The number on the bottom is our base height. Our larger triangle, the vertical height is 10. Our base height is unknown. We can multiply diagonally and divide by our leftover number. That'll give us our exact same answer. I am not going to take away this, because this is a very good strategy. And it is a very good strategy particularly for problems like this. However, this strategy right here will work for every single problem that you come encounter with. No matter the fraction, no matter the decimal, no matter how big the numbers are, no matter how small the numbers are. This strategy will work every single time. This one will work when you see that pattern. Let's try another one. Let's make this one a little bit harder. We're going to rotate the shape a little bit. Let's make it... I'm going to try and draw this one good, but I don't know if this will work out. I'm not so good at drawing the triangle part. Yeah, those don't look. I'm not good at these. All right, so let me try this again. Make it go a little bit more this way. There you go. That's a little bit better. All right. I'll label these A, B, C, and then D, E, F. So this angle right here corresponds with this angle right here. This angle right here corresponds with this one here. And then so on. Let's say that this measure right here, from here to here, that length is 2.3. The length from here to here is 6. The length from here to here is 9. What is that missing length right there? So we looked at two strategies that you could use. Pick one of those strategies. All right, somebody want to give me an answer and the strategy that they used. Aiden?
3.45.
So you found that length right there was 3.45, and how did you get that?
I started up with I did 1. Yeah, I did 2.3 equals x over 9, and then I multiplied.
Okay. Anybody set up a different proportion? Scout?
Well, I didn't set up a proportion, but you could do some sort of 39 of that. But I did, since you're adding 3 to 6 to get 9, like that's half of 6, so half of 2.3 added 2.3.
Oh, so what you did was you found, what do you have to multiply 6 by to get to 9? And you had to multiply it by half of it, right? Or not multiply it, but you were increasing it by half of that. So then if you increase that by half of it, it would give you the 3.45 or 3 3/4. Or 3, I'm sorry, 3.45. What, I'm kind of curious, like the proportion here, this number right here looks like it's representing our small triangle, and then this one is representing our larger triangle. Is it possible to write a different proportion to solve that? Haley?
Well, this suggestion, you could do 6 over 9 equals 2.8.
Yeah, and I really want to, I want to make sure that we talk about different ways to kind of write that proportion. Here we were looking at our small triangle. Here we're looking at our large triangle. Here I've got my small triangle on the top and my large triangle on the bottom. Here we're comparing the sides on the top. Here we're looking at our lengths here. So it's just different ways to write that same proportion. Every single way that you do that, here, here, and here, all give you the same solution. Let's look at one more example. This one I'm going to make overlapping. let's say that this length right here is 10, this length right here is 13. This length right here, let's make that our unknown length. And then this length from here all the way to here, let's make that 15.
What is that? Math terminology behind the
Anybody find that missing link? Still working on it? All right, Lewis, what you got? I'm sorry, what was it? 11.5. And how did you get that?
I did it.
Over 13? Yeah, and I like, again, we seem to be pretty consistent. We seem to all be using the small triangle and the large triangle. I personally prefer that method. You do not have to use that method. It's the way that I prefer. I prefer to have all of one triangle here and then all of one triangle here, rather than splitting it up. In the one up here that we looked at, you could split it up. So for example, you could just compare sides. So like the bottom of the triangle is 10, the bottom of this triangle is 13, the side of this triangle is X, the side of the big triangle is 15. You could set it up like this and get the exact same answer. I think that this is a little bit less consistent. This one always seems to work out a little bit better for me. Excellent work.